For a first order reaction, rate constant K is given as K is equal to 2.303 by T log R0 by R. Let us now discuss about the nature of the graph obtained. For that, consider the expression ln R is equal to minus KT plus ln R0. This expression is of the form y is equal to mx plus c, which represents a straight line. So, if a graph is plotted taking time along the x-axis and ln R along the y-axis, a straight line will be obtained. What will be the slope equal to? Slope will be equal to minus k and the intercept will be equal to ln R0. Now consider the expression kt by 2.303 is equal to log R0 by R. This is of the form y is equal to mx. So if we plot a graph taking time along the x-axis and log R0 by R along the y-axis, a straight line will be obtained. And what will be slope equal to? Slope will be equal to k by 2.303. We know that for a first order reaction, the rate constant K is given as K is equal to 2.303 by T log R0 by R. Now the rate constant K can also be expressed in another way, that is K is equal to 1 by T2 minus T1 ln R1 by R2. How can we get this expression? For that, consider the equation ln R is equal to minus KT plus ln R0. At time t1, this expression becomes ln R1 is equal to minus kt1 plus ln R0. Mark this as equation number 1. Similarly, at time t2, the equation becomes ln R2 is equal to minus kt2 plus ln R0. Mark this as equation number 2. Now, subtracting equation 2 from equation 1, we get ln R1 minus ln R2 is equal to minus kt1 plus kt2. But what is ln R1 minus ln R2 equal to? Ln R1 by R2. So we get ln R1 by R2 is equal to k into T2 minus T1. Or what is rate constant K now equal to? K is equal to 1 by T2 minus T1 ln R1 by R2. Now consider the expression ln R is equal to minus kt plus ln R0. Take ln R0 to the other side of the equation. So we get ln R minus ln R0 is equal to minus kt. But what is ln R minus ln R0 equal to? Ln R by R0. So now we get ln R by R0 is equal to minus kt. Now if we take anti-log, we get R by R0 is equal to e raised to minus kt. Or what is R equal to? R is equal to R0 into e raised to minus kt. What is meant by half-life of a reaction? The half-life of a reaction is the time in which the concentration of a reactant is reduced to 1/2 of its initial concentration. It is represented as T half. Let us now try to derive an expression for T half for a zero order reaction. We know that the rate constant for a zero order reaction is given as K is equal to R0 minus R by T. Now if time T is taken as equal to T half, R will be equal to R0 by 2. So the expression now becomes K is equal to R0 minus R0 by 2 divided by T half. When we rearrange, we can get the expression for T half. And what is T half for a zero order reaction equal to? T half is equal to R0 by 2K. From this expression, it is clear that T half for a zero order reaction is directly proportional to the initial concentration of the reactant and inversely proportional to the rate constant K. Let us now try to derive an expression for T half for a first order reaction. We have to start with the expression for the rate constant for a first order reaction. Now what is rate constant K equal to for a first order reaction? K is equal to 2.303 by T log R0 by R. So at time T is equal to T half, R will be equal to R0 by 2. So the expression now becomes K is equal to 2.303 by T half log R0 by 2. Now what is log R0 by R0 by 2 equal to? Log 2. You can get the value of log 2 from log tables and it will be equal to 0.3010. So multiply the value of log 2 by 2.303 and thus we finally get t half as equal to 0.693 by k. So from this expression it is clear that for a first order reaction t half is independent of the initial concentration of the reactant. How can we express the rate constant K for a first order gas phase reaction where all the reactants and the products are in the gaseous state? Now consider the equation A giving B plus C. Here the reactant A is in the gaseous state and the products B and C are also in the gaseous state. At time t is equal to 0, let Pi be the pressure of the reactant A, Pi atmosphere. Initially the products are not formed, therefore the pressure of both B and C will be equal to 0. Now at time t, the pressure of A becomes Pi minus X and the pressure of the product B will be X and that of C will also be equal to X. So what is total pressure? Pt equal to sum of the pressures of the reactant as well as the products. So when we add all these, we get Pi minus X plus X plus X, that is equal to Pi plus X. So from this, what is X equal to? Pt minus Pi. Now what is the pressure of A at time t? It is equal to Pi minus X. Substitute the value of X so that the pressure of A at time t becomes equal to Pi minus of Pt minus Pi, or this is equal to 2 Pi minus Pt. So what will be the rate constant K equal to? The rate constant K will be equal to 2.303 by T log Pi by Pi minus X. Here instead of the concentration of the reactant, we have to take the pressure of the reactant at time t is equal to 0, that is initial pressure, and the pressure at time t. The initial pressure is Pi. So we have the term log Pi by, and what is the pressure of A at time t? Pi minus X. So that is why the rate constant K is written as K is equal to 2.303 by T log Pi by Pi minus X. But what is Pi minus X equal to? 2 Pi minus Pt. Thus we get the rate constant K as equal to 2.303 by T log Pi by 2 Pi minus Pt. Pt is the total pressure.